Hello there students, in this class, in the third lecture of DLD, we are going to study the number systems, what kind of number systems are there and what are the applications of those number systems. Now simply about number systems, you can just know that these are all possible numbers that we see in our daily life or that we use in our daily life, but we will discuss them from the perspective of generally computers. So basically there are four number systems. We have four number systems here. The first and most important number system is going to be binary numbers, because we are discussing digital computers, so digital computers use these kind of number systems. Now as you can see here by the name binary, which means two things. So what are the two things? In our case, 0 and 1. It means that binary numbers can only comprise from zeros and ones, and each 0 or 1 will be called as a binary digit, or in short we can call it a bit. So binary numbers are simply those numbers that comprise from 0 and zeros and ones. These have bases of 2, as we have two numbers only, two possible values with us, so the base of these numbers is 2. So if you are trying to write any binary number like this, as I've written some number here, you will enclose it in parentheses, and then you can write a small 2 in the base, which represents that this number is a binary number. So what is the use of binary numbers? And we are trying to focus on the applications of these number systems. What are the applications of these number systems? So talking about the applications, these are basically used in computers. Their whole and sole purpose is to be used in computer. They are used in computer to represent information or data. If you are trying to store some data inside the computer, if you are trying to communicate some data between computers, or if you are trying to create some graphical images or graphical pictures or anything like videos, everything uses these bits, these zeros and ones. We will understand these things with the passage of time when we go through with this course. The second number system, which is most commonly used, is decimal number system. Now we can see the deci here, or DEC here, which means 10, which means that we have 10 possible numbers here. So any number that is made from the digits between 0 to 9 is decimal number. These are very general number used in everyday life. They have the base of 10, just like here I have given example here, 971, and I have written a base of 10 here, representing that this number is, or this number belongs to decimal numbers. So what is the use of these number systems? These are used in very common problems and common everyday life problems and scenarios. Like if you are trying to perform some arithmetic operation, like you are adding marks of students, you are trying to operate on numbers or tables to find out the average and on all these things, we can use these numbers there. We use these numbers to perform basic counting, like general counting. We are trying to count some things inside in everyday life. Apart from that, in computers we use them to name memory locations, some addresses, or in our case mostly might have seen some addresses like 192.168.10.1. Now what is this? This is an IP address, and it is a special IPv4 or version 4 address of IP. We will get to know when we will be discussing the networking, but these are used in such kind of scenarios in computers. So after that we have octal numbers. Now as I can see here, or as you can see here, OCT, octal means 8. It means that it's gonna have only 8 possible values. These are only 8 digits that we can use to represent any number, either it's in binary or decimal or in some other number system. You can use this octal number, which will use only 8 digits to represent every type of number that we have. So the digits here are going to be from 0 to 7. There is no concept of 9 and 8 here, so there is going to be no 9 and 8 in octal numbers. The numbers will start from 0 and this will end from 7. It doesn't mean that the number will start from 0. The number will be only uh, the number will be a composition of numbers between 0 and 7. So the base of these numbers is going to be 8, just like I have given an example here. Now these are very rarely used in general everyday uses. These are basically created, these were created for only computer specific tasks. So the basic purpose of them was to compact binary numbers. Now as you can say that binary numbers are very difficult to understand or remember. So to create a group of three binary numbers and to give them one, to represent them using one binary number, we can use this octal number system. So the basic purpose of creating these, developing these number systems or octal number systems was to compact these binary numbers so that we can use them properly. So an octal number actually is one number that can represent three binary digits or three bits. Some other assembly languages, if you might have seen that programmers use these octal numbers to represent memory addresses or locations, or they also use these as values too. So if you have studied computer organization or other some courses like these where you are trying to discuss the assembly language, you might have noticed that octal numbers are used there too, and these are not widely used in everyday lives, in our common lives. The last one that we have is hexadecimal. This is also commonly used mostly in computers. We have seen them. We also call them hex. We can simply call them hex instead of calling them hexadecimal numbers. So hexa normally refers to 16. So it means that we are going to have 16 possible numbers here. What are the numbers going to be? The numbers are going to be 0 to 9, but we are not going to count 10, 11, 12 as it is. So there's going to be some difference here. We are going to name them, like I can use the name A for 10, B for 11, C, D, E and F. So we can say that these numbers are from 0 to 9 and A to F, which means that 10 to 15. So these numbers, so as we discussed in the beginning, we are going to have 16 possible values here. So this is how we get the 16 possible values here. So these will have the base of 16, as you can see here. Now what is the use of these things? These are also used to compress or compact the binary numbers. Now these are more powerful than octal numbers. Why? Because a single binary digit, a single hexadecimal digit is capable of representing more bits than the octal number. That was in octal numbers we said that 3 bits will be used for an octal number will be capable to represent only 3 bits, but here we say that a hexadecimal number is capable of storing or representing 4 bits at a time, which makes some difference between the octal numbers and these. So some other uses of these are, they are used in color coding. Like if you have used HTML, you can use such kind of colors like EF. Now this will create a light gray color for you. So we also use them for color coding. Apart from this, these can also be used in MAC addresses, computer addresses in MAC addresses, or you might have seen in the Bluetooth options you see some addresses like these 2A BC, like these are what, these are generally MAC addresses. IP addresses, the normal IP addresses generally use decimal notations, but we also have version 6 of IP addresses which use hexadecimal values, and some other memory addresses also use them. But the representation techniques for hexadecimal number is, there are three options for us. The standard option is to write them like this. If you have an hexadecimal number like 12AB, you would write it like this. You can also write them like this by just terminating them with an H, which will help which will have this representation here. Or we can also start the hexadecimal number with 0x, then we can write the remaining number. So we can consider that this 0x is actually pointing out towards this number as being as a hexadecimal number. So these are the four number system that we have in computers and daily based lives, but we are going to be focusing on binary numbers because we are using computers and we are studying computers. So this is it from this video. In the next class we will try to discuss some important conversions between these number systems. We are not going to discuss every type of conversion, we will discuss only a few of them. Thank you from here.